Hello and welcome. So today we're jumping into a really fascinating, kind of mind-bending idea. What if reality has this foundational layer, a layer that our entire scientific method is just completely blind to?
It's a wild question, but it's worth thinking about. I mean, the scientific method is, without a doubt, the most powerful tool we have for understanding the universe. But what if the very thing that makes it so powerful, its obsession with separation and measurement, is also the thing that limits its vision?
Because when you boil it all down, that's what science does. It's all built on this one single act. We separate things, we categorize them, we isolate variables, and then we measure them. It's how we take the beautiful chaos of the universe and turn it into data we can actually understand. It really is the bedrock of everything we think we know.
But here's the twist, right? This whole process of making distinctions, as incredible as it is, seems to leave us with some really baffling paradoxes. You see it in quantum mechanics, where just observing a particle seems to change its state. That's the famous measurement problem. And then you have cosmology, where gravity just refuses to play by the same rules as all the other fundamental forces. It's almost like we're trying to understand a seamless piece of fabric by only looking at its individual threads.
So, how do we get past these paradoxes? Well, the idea we're digging into today suggests it's not about finding some new equation. It's about adopting a whole new way of seeing nature itself. It's a tale of two realities.
And this new way of looking at things uses that classic map versus the territory analogy. So, level 2, that's the map. It's the world we're all familiar with, the reality we build up through measurement and distinctions. But level 1, now that's the territory. That's the singular, whole fabric of reality that exists before we even start trying to draw lines on it.
Just to be super clear, level 2 is where all our science lives. Every bit of data, every observation, every physical law, it all happens here. This is the reality we see through our instruments. And it's incredibly useful, don't get me wrong. But according to this paradigm, it's not the whole story. It's a derivative reality.
Which brings us back to level 1. The source material for this describes it as a single, unbroken whole. I mean, at this truly fundamental level, the universe isn't a collection of separate parts, it's one indivisible thing. The really radical idea here is that our very act of measuring is what creates the illusion of separate parts in the first place.
And, well, this leads us to a huge problem, the central conflict of this whole idea. If our scientific tools, our very methods of observation, can only work in that world of distinctions, in level 2, how could we ever prove that the seamless reality of level 1 even exists?
And this is where we kind of hit a brick wall. It's stated pretty plainly. You cannot use the tools of level 2 to prove level 1. It makes sense, right? The map can describe the territory, but it can never prove the territory exists outside of the map's own language. And that's a profound challenge.
You see, this isn't just a practical problem. It's a problem with the nature of knowledge itself, what philosophers call an epistemological dilemma. If you can't design an experiment to see something directly, conventional science says it might as well not exist. So it really feels like a complete dead end. But is it?
Okay, this is where things get really clever. Because a new kind of challenge demands a new kind of methodology. If we can't prove level 1 directly, maybe we can prove it indirectly, with a seriously ingenious workaround.
The proposed solution is called the analog approach, and it's basically a two-step process. First, you build an analog of level 1. This would be a formal model, maybe a crazy complex computer simulation that's built on the core assumption that reality is one single, whole object. You don't program in separate particles, you program in one interconnected system. Then, and this is the crucial part, you verify its behavior. You check to see if the outputs and the emergent behaviors of this model perfectly match the world we actually measure in level 2.
So the whole point, the big shift in thinking is this. Proof no longer comes from direct observation. We're not trying to take a picture of level 1 anymore. Instead, the proof is in the performance. If our analog of a unified reality can perfectly replicate the complicated, distinct things we see all around us, then we've validated the model.
So, you might be asking, why go through all this trouble? Why are we chasing an unseeable reality? Well, because the potential payoff here could be a completely new path forward for fundamental physics. The ultimate goal here is to get to a new kind of clarity. It's about finally finding a way to resolve those paradoxes that have stumped physicists for a century. The weirdness in quantum mechanics, the trouble with unifying gravity. It's about acknowledging the limits of our own perspective. I mean, think about it. If the measurement problem is caused by the very act of measuring, a model of level 1 might show us exactly why that happens.
And that leaves us with this final, really provocative question to chew on. If we can build a model based on this unified level 1, a model that perfectly predicts and explains everything we see in our measured level 2, does it really matter that we can't directly see its foundation? What does that tell us about the nature of proof, and maybe about the nature of reality itself?